Hello everyone. All right, so in this video, I'm going to show you how to do modeling with first order ordinary differential equations. So let's get to it. All right, so the formula that we're going to use is going to be dq dt, where q measures the amount of salt in a tank or a solution, you can say, is equal to rate in, so let's use Rn, concentration in, that's Cn, minus rate out times concentration out. Now, usually in a problem, you will be given this component, and this component. So you just have to figure out what is concentration out is. Now, you should also know that the concentration is given by the amount, which we're going to be using Q of T over the volume, which is V of T. So we can also simplify the volume depending on rate in minus rate out. So it's going to be a linear function. So you can say this is Q of T over some initial volume plus rate in minus rate out times T. So that will determine the function V of T. So that's how you can figure out concentration out. So we can say this is C out. And then you have the initial condition. So that would be Q of 0. So let me write that up here, Q of 0, which will measure the amount, initial salt amount in a tank. So this will be the initial amount. The initial salt, let's say, amount. All right, so knowing that, now let's go ahead and figure out, let's set up one differential equation and see how you feel. So here is our first example. So we're going to set up the differential equation with an initial condition. Now, of course, you can solve it, but setting up is the important key for this video. So let's go ahead and do that. So let's see what's given to us. So a tank with the capacity of 200 gallons initially contains 50 gallons of fresh water. So initially contains 50 gallons of fresh water. So you have your initial volume, which is, let's call it V0, that's 50 gallons. And fresh water, that's your initial condition because initially the tank has no concentration, it's just fresh water. So we're going to say the initial salt amount is going to be 0. Now for the second part, a solution with the concentration of 5 pounds per gallon enters at a rate of 3 gallons per minute. So that's giving us our concentration in and rate in. So we have a concentration of 5 pounds per gallon comes in at a rate of 3 gallons per minute. And a well-stirred mixture is pumped out at the rate 2 gallons per minute. So we know our rate out, that's going to be 2 gallons per minute. So we just need to figure out what is concentration out. So we're going to be using the formula that I wrote previously. Concentration out is going to be measured by the amount over V initial plus Rn minus R out times T. So Q is just the unknown. And we know the initial volume, which is 50, and then Rn, that is 3, and R out, that is 2 times T. So that is our function for concentration out. So we have everything. Now we just need to set up an initial value problem which describes the amount of salt in the tank. So we're just going to set it up, and that will be for this problem. So let's go ahead and set this up. So we have ds dq dt is equal to Rn Cn minus R out C out. So then I can just plug in what is given to us. We have dq dt is equal to Rn, well, that is 3, Cn, that is 5, minus R out, that is 2, and C out is this function we wrote down at the bottom. So that would be Q of T over 50, and then 3 minus 2, that's just 1, so plus T. So that is our concentration out with the initial condition of Q of 0 is 0. So that will be the setup for this process. And now the way you would solve this would be using the integrating factor, because this is a linear equation. So for this type of problem, it's either going to be a separable equation or linear equation. So you can use the integrating factor method. All right, so I hope this makes sense. Let's go ahead and try another one. All right, so let's go ahead and set up this problem and let's see how you perform. So again, you can pause the video and then check your answers with me. So we have a 200-gallon tank initially contains 50 gallons in which are dissolved 5 pounds of salt. So we have initial volume, which is 50 gallons. Now this 200, that's the capacity of the tank. So you can kind of think of that as the final volume, VF, which is 200. After it hits, so once it hits 200, it's going to start to overflow. So you can think of it that way. That's that info. So we have 50 gallons in which are dissolved 5 pounds of salt. So that's your initial salt amount. So we have initial salt amount is going to be 5. The tank is flashed by pumping pure water into the tank. So you're inputting pure water at a rate of 4 gallons per minute. So concentration in, well, there's nothing coming in. It's pure water coming in. So we can say concentration in is 0. It's coming in at a rate of 4 gallons per minute. And a well-mixed solution is pumped out, so that's R out, at a rate of 3 gallons per minute. And of course, we need to figure out C out based on what is given to us. So C out is going to be, again, the amount Q over V initial plus Rn minus R out times T. And we know what this is. So we know this is Q of T over initial volume, which is 50. And then Rn, that is 4. And then R out, that is 3 times T. So that's our concentration out. Now, for the first part of this problem, we can just say, let's call that part A. We want to know the time when the tank has filled. So when it is full, well, we know it's going to be full when it hits 200. So we know the function for volume is going to be the initial volume plus Rn minus R out times T. And that's the bottom of the concentration out. So we can just put that in there. So we have 50 plus Rn, which is 4. R out, that's 3. So just 1 T is equal to 200. Well, now let's go ahead and solve for T. So we're going to subtract 50 from both sides. So we have 150 is equal to T. So that is the time when the tank is going to be filled. So that's part A. Let's call this part A. Now, then we're going to write the initial value problem, so which you already have. We just need to set it up. That describes the amount of salt in the tank at any given time T before the tank is full. Okay, so we know that. So let's call that part B. Our differential equation dq dt is equal to rate in, concentration in, minus rate out, concentration out, with the initial condition, which we're going to fill in. So we know our dq dt is equal to Rn. Well, in this case, Rn is 4. So let's call this as 4. Concentration in is 0. Minus R out is 3. Concentration out is Q of T over 50 plus T. And that will just simplify to our system to be dq dt as, so this will go to 0, of course, minus 3 Q of T over 50 plus T. And you can solve this using integrating factor, or you can use the separation of variables. And the initial condition we have for this problem is right here. We have q of 0, q of 0 is 5. So with the initial condition, q of 0 is 5. So that will be the setup. So yeah, so that's how you do tank problem. There is also compound interest, which is also similar idea, which you can look into it and hopefully things will make sense. All right, so I will complete it here. I hope you enjoyed the video. Feel free to like and subscribe. Until next time.